All right, guys, for this video, we're going to take a look at these three example questions that I've given you. It says, let's try to take all three and create graphs for them. So our objective is to use Desmos to create a graph for each of these. It says, graph the starting amount and the fifth term of each. Okay, so we're going to need to find the fifth term of each. Now, in regards to number one, we are not given the fifth term. We are given the first term, the second term, and of course our zero term. One way you could do this is just by finding out what the multiplier is, filling out the rest of them, and then graphing each point. But I'm actually not going to do it that way. Instead, we already know our a term, which is 0, 4. That means our a term is going to be 4. And we're going to use this to create a function or to create an equation kind of similar to what we see down here for this table. What I have actually done is copied this table down here onto this paper, so we have a little extra room to work with. And let's go ahead and write down what we know. So we know that our a term is going to equal 4. Now we just need to find our b term. We can find our b term by taking any term and dividing it by the one that comes before. So let's go ahead and take 9 and divide it by 6. So 9 divided by 6 is going to be equal to 9 divided by 6, 1.5. So we know our multiplier, also known as our b term, is going to be 1.5. Let's go ahead and write out an equation then. Equation y is equal to 4 times 1.5 to the power of x. So this is actually the equation for our table. We can use this equation from our table and graph it on Desmos and find out what that looks like. Okay, so I'm just going to open up a new window. I already have Desmos as one of my most commonly used apps. So here we go. Y equals 4 times 1.5 to the power of x. Now remember, we're going to graph all the way to the fifth term. So we need to make sure that all of those are on here. Now, one way to work with Desmos is you can use the little wrench here. We know that we want for our x-axis to be at least 0, so let's make it at -4. And we want it to go up all the way to the fifth term, so we can do that. Let's actually find out what that fifth term comes up to. So our fifth term is over here somewhere. We can follow this around. And there it is. And closer, closer. There. So it's actually 30.375 or 30.3, let's say about 33.38. So let's actually switch this so that our x-axis goes from, x-axis is fine, our y-axis, we want to go from 0 to, let's just say 40. Okay, so now we have our equation and our points. Now 5, 30.38, we can actually write in here. 5, 30.38. Is that right? Yeah. So we can have both of those on here. All right, now if you are me, you have your snipping tool handy. It looks kind of like this, like some scissors and a little circle. So I'm going to go ahead and click on that and click New, and I'm just going to snip this. So the snipping tool is actually really handy for just making little screenshots. So once I have it here, I can just Control Copy, and then just bring it onto any old document. Let's say we want to use the document we were using before. Okay, I can just hit Control Paste, and it's a little big, so I'm going to resize it, but there is our first example as a graph. where we have its first term, or sorry, the y-intercept at 0 term all the way up to its 5th term. So that's one down. Let's go ahead and take a look at the second example. We can get rid of all of our first example stuff here because we're not using it anymore. And it gives us y equals 3 times 4 to the power of x. Well, that's going to be really easy to work with Desmos. So let's go back to Desmos. We now have y equals 3 times 4 power of x. And look at that, this one's already graphed for us. Now if you look, the 5th term is actually way up there. So what we can actually probably do is figure out what the answer is going to be by just plugging in a 5 for x. So it's going to go all the way up to 3072. That means we're going to need a much wider or longer, taller graph to work with. So let's go ahead and change this back to an x, and let's change our y values to up to 4000. All right, now we can see it pretty well. We can actually move this around a little. So our y-intercept was over here at 3, but by the 5th term, we get all the way up to 3072. So let's go ahead and type that in, 53072. 53072. And now we actually have both points listed on there. Now for the snipping tool, many of you, if you're using a Windows type computer, you can just type in the little search box here, snipping, and it should pop right up. Click on it, hit new, and then we're just going to take a little snip, this, copy, and we'll paste it back onto our document over here. Again, way too large. We can resize it just by clicking and dragging it into a smaller size. And now we have both right next to each other. 2 down, 1 to go. So it says, Gerald drops a ball from a height of 80 inches. After falling and bouncing, it returns to a height of 64 inches. How high will it be on its 5th bounce? Let's give ourselves a little room. Well, we know the first bounce, or at least our 0 term, is going to be 0, 80. 0, 80. So that's going to actually mean that our a term is equal to 80. Now our b term we have to get by taking the second value and dividing it by the first value. We also know that this is going to be a declining exponential function because it is getting smaller with each bounce. And that should be pretty obvious why. All right, so let's take 64, let's divide it by 80, and let's find out what we get. 64 divided by 80 gives us 0.8. So we now have a b term. All right, we have our b term, we have our a term, we can make an equation. So let's insert an equation here. Y equals, try that again. Y equals 80 times 0.8 to the power of x. And we're going to take that same equation and just put it into Desmos. So let's go back to Desmos. All right, for this one, we have 80 times 0.8 to the power of x. As you can see, this is not really looking that good. Well, we can actually find out what that 5th term is going to be by plugging in a 5 here. And it gives us 526 let's say 21. You can actually write the 4 in there as well. All right, so now we need to change these to actually fit. Again, we only need from about, let's say, -2 to, let's say, 8. And we know that our starting amount was 0. Sorry, it was 80. So we can actually say, let's just say 0 to 80. All right, and that should give us a pretty good idea of what this should look like. Oh, yeah, there we go. All right, and here we go. So for this one, we can actually zoom out a bit as well. It looks like we start up here at 80, and as you can see, it's a negative graph. It's getting smaller. This represents a ball bouncing. So here's the first bounce, comes up to here, bounces again, comes up to here, bounces again, comes up to here, bounces again, comes up to here, bounces again. On that fifth bounce, we get this point, and we can label that. All right, let's do the same thing. Grab our snipping tool, new, copy, and paste. Resize, and there we go. So we now have our 3 examples all sketched out on graphs thanks to Desmos and the snipping tool. And this is one way that you'll be able to turn in your homework a little bit later if you prefer. Another method is just to sketch it. So draw yourself a couple of axes, draw over here at 0, 80, draw approximately where you would expect that fifth term to be here, and then just connect them with a curvy line. All right, that's going to conclude this video, and hopefully you guys learned something from it.